Hey everybody. For our asynchronous lesson today, we're going to kick off the next chapter. It is a super short chapter. In fact, it's really just 3 days. So I'm going to introduce a set of functions to you today. They're going to be what I'm going to call our parent functions. And then on Friday and Monday, we'll go through what it means when I take that function and move it left, right, up, and down. We'll be doing different transformations with those functions. So our focus today is just figuring out what the graphs look like. I've got a few of them to go through, and that's going to be it for today. All right, so today we're going to take a look at just 6 main, what I'm going to refer to as parent functions. We're going to take these functions and stretch them out and move them up and down and left and right and all kinds of stuff over the next week. So I just need to get you familiar with these 6 functions. The first one's nice and easy. F of x equals x. The input equals the output. So if you plug in 1, you get out 1. If you plug in 5, you get out 5. Now, as far as what the graph looks like, it's just a straight line. It's a line with a slope of 1. The y-intercept is 0. If you remember y equals mx plus b form, the slope is 1. The y pretty plain, pretty simple, not a big deal with that one. Second one is f of x equals x squared. The output is the input to the second power. So 2 squared is 4, 3 squared is 9, negative 2 squared is also 4, negative 3 squared is also 9. And so we get this nice symmetric shape. We get this parabola. The vertex is at the point 0, 0, which I can't write super clearly right now, but I can put that on there. The vertex at 0, 0. That looks okay. Aside from that, you guys know what a parabola looks like, so there we go. F of x equals x cubed has a little bit different shape to it. It increases a little more quickly. 2 to the third power is 8, so this thing goes off the scale pretty quickly. It levels out at the middle. I can't exactly call that the vertex, but that point where the wiggle changes from curving down to curving up, that also happens at the origin, the point 0, 0. And when you're doing your homework assignment, you're just going to plug in points. You're going to plug in 0, plug in 1, plug in 2, plug in 3. For this one, you're not going to be able to plug in very much because it goes off the scale so quickly. It gets to be a large number very fast. Next one for us to look at is the square root function. The square root of x. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And so as the inputs are getting to be really big, the x values, the outputs are getting to be large also, but not quite as fast. The square root of 100 is only 10. And so this graph kind of levels out as you get farther away. Significant point on this one is the origin. 0, 0 is the place where it begins. You might be starting to get an idea that the point 0, 0 is a fairly significant point. The penultimate one is the absolute value graph. If you had to describe the graph of the absolute value function in just one letter, that letter would be V. The vertex of this graph is the point 0, 0. The place where the graph switches from having a slope of negative 1 to having a slope of positive 1. And really, this is just the graph of y equals x, except all the negative values have been flipped up to be positive, giving it this always positive V shape. This is the absolute value graph. And then finally, the only graph that does not contain the point 0, 0, the graph of y equals 1 over x. 1 divided by 1 is 1. 1 divided by 2 is a half. 1 divided by 10 is 1/10. It gets to be very, very small. And so we see this behavior where if the x value gets to be really big, the function gets to be really small, approaching the x-axis. What's a little bit more difficult to graph is the vertical asymptote. And we'll talk more about that word asymptote as we look at transformations of this graph. But if x is a very small value, if x is 0.01, well, 1 divided by 0.01, that's like 100. And so as we get close to the y-axis, this graph gets to be really big. And then all the same stuff happens on the back side of it when x is a negative number, except we've got negative values as the outputs, so it's down below the x-axis instead of above the x-axis. This graph is something called a hyperbola. Instead of parabola, this is a hyperbola. That's just the name of a graph like this that has asymptotes, lines that the graph is getting close to as we get farther and farther away from the origin. Now, the intersection of the asymptotes would be the point 0, 0, but the origin does not actually show up on this graph. And that's that. Those are the six functions. Your assignment is just to graph them to have a nice resource so that you can look at them and refer to those graphs as we move them left and right and up and down over the next couple of days. We will be quizzing on this very short chapter on Wednesday of next week. So it is important that you keep up. Get this assignment, crank it out. We're going to have another assignment over the weekend that's just going to be transformations of these 6 graphs. All right, that's all I got. Have a great day. We'll see you on Friday.